the video solution of exam 15. We will start with our exercise, since many of you are not interested in access exercise. First of all, I open any directory, for example this PC, \\ubz 01 fst. Since I'm not using a university computer, I have to digit also .unibz.it. Okay, not exams but courses, exam Coletti. You search for yourself and you copy all the content onto desktop. Okay. Now we have to start R. I imagine and hope I don't close this window, I just iconize it. I imagine and I hope for you that you have already started it. I was not so smart as you should be, and I have to search for it. Lectures and file examples are portable. Okay. So I start our portable. I'm currently using version 3.3.1. It's the new version I will use during the academic year 2006-2017. Well, there is basically no difference with respect to previous versions. Packages, load package, our commander. This is also something you should do before the exam if you are smart. So you save at least a couple of minutes. And then I open also Word to write my comments. Come on. Who will be faster, Word or R? R wins. Okay. I change my working directory. Okay. Okay, now I'm ready. This directory is not necessary anymore. Okay. So the data set nuclear given in workspace nuclear.rdata. So pay attention, I usually give you a workspace, but not always. Sometimes I ask you to load the workspace directly from inside our commander. In this case, instead, I give you a workspace. The workspace is this one here. Okay. So file. Well, you can either from here file load workspace, or from our commander data load dataset nuclear.rdata. Okay, loaded. Let's take a look at it. Okay, you have also the code book. It's the third page of this exam. Describe variable prior plant using numbers and an appropriate graph. Okay, so summaries. A prior plant is a binary variable, so it's nominal. So I have to use frequencies. Don't use numerical summaries, please. Okay, done. Let's write here. Prior plant variable. Okay. So we have a total of 32 cases. Okay, 68%, 69% are 0, and 31% are 1. Save. I go to my desktop and I save it as, let's see, exam.doc x. Okay. Now an appropriate graph also. Let's see. Graph. Well, an appropriate graph in this case could be the pie chart, but I don't like it particularly when there are only 2 cases. It's ridiculous. The bar graph. It's okay. Okay, here the bar graph. Okay. I will ask also to use color blue and white. So let's see. Here come call equals C. Okay. I told you I would ask because I'm not sure that it works, and I'm wondering why doesn't it work. And if I type just one true, mystery. Okay, so I will remove it from the exam because it doesn't work. Okay. By the way, I will remove it from the exam, but in the exam I will still ask you for the graph. Okay. Convert variable same engineer to ordered factor same engineer 2 using 1, 3 as few, 4, 9 as some, 10, 15 as many, and above 15 as much. Okay. So a command data active data set, manage variables in the active data set, record variable, same engineer, same engineer 2, low 2, 3 equal few, 4 to 9 equal some, 10 to 15 equal many, 16 to high equal much. You could also write 1 to 3, but here, unless you know exactly how many there are, I press OK, and at this way I'm building just a factor. I want an ordered factor, however, so you can put here ordered, okay, if you want. This is a possibility, and rerun the entire, okay. Alternatively, instead of putting it here, you can type nuclear dollar same engineer 2 equal ordered so I have to run again this one and then this one. Okay, let's take a look whether it is not necessary to do at exam, to do it in 2 different ways. I just showing it to you and to take a look, but taking a look, it's always a good idea. The structure of nuclear same engineer 2. Okay, you can see it's another factor. It has, however, a little problem. Look, few, many, much. Okay, well, R has not understood that the order must be few, some, many, much, and uses alphabetical order. Okay, so we have done, let's say, 75% of the work. Let's see what happens if you want to do also the right order. Levels equal C. I am trying, I am not sure that it works, so I will redo this one first, and then do this ordered nuclear with the optional parameters levels equal. Okay, now let's see the structure. Okay, this is correct. So this is the trick to use also the correct levels. Okay, but it's not necessary, but let's copy it on the Word file so the professor gets to know that I really did it. Okay. Check whether the average of cost depends on same engineer 2 on the population. Well, if you did not do the previous point, use same engineer 3. Okay, so same engineer 2, it's a ordinal variable, which here must be considered nominal. Cost, it's a scale variable. The test here, it's the test on the averages, it's the ANOVA. So groups, same engineer true, cost. Okay, that's it. So first of all, I write H0 hypothesis. ANOVA H0. H0 is the average of cost group. So the average of cost category by category of same engineer true is the same. Or if you prefer the average of cost, it's the same for each category of same engineer true on the population. Okay. Alternative hypothesis, at least one an average is different from the others. Okay. Let's see the result. Please don't copy everything randomly. Copy only the relevant information. In this case, the relevant information is this one. The per larger than f, the significance. So significance. Okay. The other relevant information are the sample means, which are these ones. So significance, it's larger than 5%. So sig larger than 5%, even though slightly larger. It means that H0 is accepted. We cannot say anything. Okay. In particular, in this case, we cannot say anything because it's too large to say that they are different, but it's not so much large. It's only slightly large. So probably this one, for example, is different than the others, but we cannot say it. Okay, test is finished. Check whether the distribution of cost depends on same engineer true on the population. Apparently, it seems the same question, but look at the distribution of cost. It means that you must use the other test, the Kruskal-Wallis. So, which tests the distribution? Non-parametric test, Kruskal-Wallis. Same engineer true, cost. Done. We'll take everything. First of all, I write Kruskal-Wallis. Then I write H0, distribution of cost. It's the same, is in the same position. H1 at least distribution is shifted. Okay. Significance. Again, unfortunately, it gives more or less the same result, a slightly non-significance. Check whether the average of time per meet is equal to 12 on the population. This is clearly a student t-test for one variable only. So let's write student t-test for one. H0, average of, here I forgot, is in the same position on the population. Because I remind you that if you just want to check on the sample, you need the descriptive statistics and nothing else. Average of time for per meet is equal to 12 on the population. H1, average of time per meet, is different from 12 on the population. Let's see. Statistics means single sample t-test, time for per meet, time for per meet. Null hypothesis 12, mu equal to 12. Okay. Here you have it. The value of the statistic is this one, degrees of freedom, p-value, significance is equal to this one. I repeat, don't copy everything just because you're lazy or because you don't know what you're doing, because I won't consider it correct. So I copy only the sample mean, so sample mean of time per meet. Okay, the significance. Okay, so significance is much smaller than 5%. It means that H0 is rejected. It means that average on the population is not 12. Well, in fact, average on the sample is almost 14. Check whether there is a relation between time for permit and time for license on the population, building also a graphical representation. Okay, time for permit, it's a numerical variable scale. Time for license, same thing, is a scale numerical variable. Okay, so the graphical representation, it's obviously the scatter plot, and check whether there is a relation, is the Pearson with its, the Pearson correlation with its test. So Pearson correlation. So first I build a scatter plot. Scatter plot. Where is the scatter plot? Scatter plot. So time for license and time for permit. Well, I remove a lot of options, or they're already removed. Fine. Copy as bitmap. Here you have. There seems to be a relation. A negative relation. So the more it takes to take the license, the less it takes to take the permit. Let's see what this does. Where is it? Where is it? Correlation test. Well, correlation matrix just to get the coefficient. Correlation test to do also the test. Time for license, time for... I have to pick two. Pearson, two-sided. Okay. Don't copy everything. Better, copy everything, but then remove things which are totally not necessary. Come on. My word are stuck. Okay. Okay, this is a sample. Sample correlation is equal to minus 0.47. H0 equal to 0 on population. H1 different on population. Okay, significance much smaller than 5%, so significance much smaller than 5%. It means that H0 is rejected. It means that correlation on the population is not 0. Unfortunately, there is no famous test to check whether the correlation is 57, 50, 47. Okay. This just check whether the correlation is 0, not 0, or it can check whether the correlation is smaller than 0 or not. Okay. Let's go on. Build a new variable inside the dataset called total time equal to time for permit plus time for license plus 5. Well, there are two ways to do it. Either you build it manually, nuclear dollar total time equal nuclear dollar time for permit plus nuclear dollar time for license written with a C plus 5. Okay, this is an alternative. I won't do it. Okay, the other alternative is doing it from here. Compute new variable total time okay, done. Let's check because you never know. Okay, total time is here. Seems okay. You can check a couple of values. It will be okay. Okay. By the way, in order to avoid losing everything, I start saving save script, which is the most important thing, as exam .r. I actually don't look at the script and at the output, but in case your Word file get lost or something happens, it's better to save them, and I save also the workspace. Okay. Build a new variable inside the dataset called ABC equal to cost, but with the first 20 values set to NA. Or at least you must do it manually. So nuclear ABC equal. Well, I will first of all create a duplicate of cost, and then I will simply set the first 20 values to NA. It's easier. You could set directly the values from 21 up to 10, but it's much more difficult. This is okay. And then ABC of 1 to 20. Let's see. Okay, you can see. Done. Restrict dataset to only plants not in the northeast. Pay attention, not in the northeast. And describe graphically and numerically variable capacity. Well, first of all, let's restrict. So data, active dataset, subset active dataset. For the new dataset is a nuclear 2. And the subset expression is northeast. Now I take a look at the code book here. Okay, northeast equals 0. 1 indicates that the plant was constructed in the northeast. So equals 0, or if you prefer different from 1, but equals 0. I think it's 0, the other alternative. Let's see. Oh, error text. Why error text? Northeast spelled correctly. Let's take a look at the values. 0, there is 0. Why is error text? I try to resubmit, again error text. Equal. It's equal. Submit. Okay, because the one equal is the assignment. How can I now understand that I did it correctly? You still see the error. Because R is pretty stupid with error messages. I'm sorry, but you have to remember which was the number was the last one. The last one was number 10. I resubmit. I don't get a new one, so I don't get an 11th error. So this is the old message. Okay. If you prefer, you can remove all the messages every time. Okay, so I have my new data set. I use it. Okay, and now I have to describe graphically and numerically variable capacity, which is a scale variable, so it's pretty easy. I can describe it graphically with an histogram or with a box plot, as you prefer. By the way, I just pasted this thing here, so the professor will know that I did also the rest. Okay. Now, capacity on subset. Okay, first of all, an histogram. When I'm in a hurry, I usually prefer the box plot, because the box plot is always correct. The histogram may have a strange binning and you will have to redo it. So usually the box plot when you are in a hurry. And numerically, okay, save. This part seems over. I turn the page. Oh, there is nothing else. So this part is over. I close Word. I close R command. And no, I save the script. Save the script as. Is it possible that every time I have to respecify the name? Save the output as. Save the workspace as. Exit, command and R. No, I have already saved. Okay. Let's collect all the 20 files. Here you have the doc. These are the files necessary. The workspace. Okay, we have everything. Now switch to Access. By the way, for the ones of you who stop here, I just teach you how to copy them back. You take them, you drag them here on the windows that you have left open. Okay. It will ask you whether you want to overwrite, and obviously you first of all check that you are copying from the desktop to the network directory and not vice versa. I remind you that 5% of the students lose files. Okay, and then I click on replace the file in the destination. Okay, you don't give me 20 copies of the same file, otherwise I'm not able to know which one to correct, and I will write -1, -1, -1. Okay, that's it. Now let's switch really to Access, and the people who are not interested can turn the video off. Open Car Workshop. Enable content, create form exam1 to insert modify mechanics, and the repairs they are in charge of. So an easy form wizard, mechanics. Do I specify which field? No. Let's first name, last name, nothing else. And the repairs they are in charge of. Repairs ID problem, and that's it. Okay, next, mechanics and repair subform, finish. I have to rename the form, at least the main form, please, and call. I have to close it. Rename it as exam1. Okay. Now I have to apply the locking view. I have to open it in design view. Go to property sheet. Okay. This is the main form. On the main form, I can only insert and modify mechanics. Okay, insert, delete, I cannot do it, and modify, yes. Okay. And now, and in the other one, lock the form to avoid mechanics deletion, to avoid mechanics deletion, insertion and modification. Also insertion and modification. So, I have to lock also insertion and modification. Okay, can't do anything. Okay, and to avoid the repairs deletions, so I close it, save, into repair subform, design view, property sheet, deletion, no. Okay. Oh, that's it. How many repair? Each one. Okay. Create query exam2 that calculates for each repair the cost divided by the total number of hours. Use work hours in table in charge. So create. Well, we are expert to use query design for each repair, so I need at least the repair ID from here. Okay, I need the cost. Okay, divided, so cost divided by hours, which is equal to the cost divided by work hours, which unfortunately is not here, but it's in another table. Okay, but look at the schema above. It's in another table, but the relation is one to many. So for each repair, you have several in charge records. It means that first you have to calculate the sum. You can see the total number of hours, and then you can do it. So we did it wrong. We first had to build another query, a query that we use. So query design from in charge. Let's see. Okay, we get repair work hours. It's a summary query. we have to sum. So first we sum the number of hours for each repair. Okay, now we close and save it. Let's leave query 1. Okay, now using data from this query, okay, and from table repairs, we have to connect them manually. Okay, we can repair ID, the cost by hour, colon, the cost divided by sum of work hours. So this is one of the cases in which you have to build an additional query before building your query. So a query which does some calculations which you can do on the fly automatically. Or better, if you are able to, you could do but with using advanced tools. But since you can do it in this way. Okay. Is it everything is okay using it? Okay. Perfect. Save. The name is exam2. Okay, I close it. Create query exam3 that lists, at this time I will read it completely before starting doing things, that lists all the cars with plate starting with letter A with their owners and how many years have passed from by date till now, sorted by surname. So we need the cars, the ownership and the owner. Okay, so I think we can do it in one single step. Query design, I need cars, ownership, and customers. Okay, I need car plate, first name, last name, and how many years. So the time passed from by date till now. So I need how many years, date diff from date, which in Access, I remind you, it's today, comma, I think it's comma or semicolon, I don't remember, it will give me an error in case, by date, comma, in years. I remind you that if you're using an Italian Access, it's AAAA, and a German Access, JJJJ. Let's see. Oh no, there is an error, so the comma, it's a semicolon for me, for you it may be a comma. Okay, let's see whether it works. Error. Well, let's check this date diff using the builder. Function, building function, date time, date diff. First the interval and then the dates. So, you see what happens when you don't study regularly. And then I think the dates go switched in the other direction. Okay. First the oldest date, then the more recent. Okay. I think it's okay. Save exam3. Okay. Create query exam4 that displays customers without a car. This is a left-right join. Okay. You could use the wizard because you can see find a matched query wizard. So if you want, you can do this one if you understand what does it say. Otherwise, I will talk to you how to do it. So first of all, cars, ownership, customers. Well, actually, you don't need the cars table, so just the ownership. Okay. Now, I will include all the customers. Okay. So selection true. Okay, so I will include all the customers and only the ownerships which match. I need, for example, tax code, first name and last name. Okay, and now I take, as you remember, ID for example, and I write here null. okay, is null. So I'm searching for all those customers, okay, who don't have a corresponding ID in table ownership. Since this special join, if you choose number one, if a customer doesn't have something here, will never display it, full stop. So it will return an empty table. If you choose number two, you include all the records from customers, okay, and only those records from ownership where the joined field are equal. In case a customer doesn't have any ownership, it will still return something, but something empty. Okay. Well, I will just to show it, not write is null, and show it to you. So you can see some of them are null. So you just write is null. Okay. And you get only the ones who don't have a car. Why do we have in our database customers without a car? I don't know, but we do have some of them. My access has stuck, obviously. So many. 264 customers without a car. Okay. Okay, save. And I write it as exam4. Okay. Now the exam is over. I have to copy back this one, which is the only one I didn't copy before. Okay, let's check whether I have copied everything. Okay, car workshop, exam.x, nuclear, our data, nuclear.txt, why? No, sorry, this one is not here. Okay, everything is okay. And I'm over. I wait for it to complete, and now I can stop.